Hi everybody. In this video, I am going to talk about one variable optimization problem. It is the chapter 1 of the textbook. So, I will be talking about the procedure that can be used to solve problems using mathematical modeling. And also, I will illustrate this procedure called the 5-step method. Finally, I will explain an example to understand the method. The 5-step method. So the 5-step method of solving applied problems using mathematical modeling. First step is ask the question. Under this, you should recognize the variables. So first make a list of variables. Then state all assumptions according to the problems. So finally, state the objective. So these three are going to be under step 1. Then second step, we should select the modeling approach. It is based on your problem. So I will explain how to do this. Third one, formulate the model. So restate the questions in step 1 to match the model in step 2. Fourth one, solve the model. Here, apply the general solution procedure to the specific problems. Last step, answer the question. So these are the steps of 5-step method. So I will explain this step using an example. This is the example from the book, example 1.2.1, pig selling problems. A pig weighing 200 pounds gains 5 pounds per day and costs 45 cents a day to keep. The market price is 65 cents per pound, but falling 1 cent per day. When should the pig be sold? Okay, understand the problem very clearly. Then go to the step 1. What is step 1? Ask the question. Under this, as I mentioned before, we should recognize the variables. What are the variables? Okay, first, they are talking about the time. Date. When should the pig be sold? Therefore, we should have a variable for the time. Then, they are talking about weight. So, W equal weight. Next one, price. And cost of keeping pig days and revenue. Then finally, we need profit from sale of pig. This is the list of variables. T, W, P, C, R, PR. Okay, next, assumptions and constraint. So, what are the assumptions? You see, weight of pig. So, let me write down an equation for weight of pig, which is W, which is for the W. So W is the weight of pig. So at the beginning, pig 200 pounds, but problem says pig gains 5 pounds per day. Okay, therefore we should add 5 times 5 pounds per day, but we use the T number of days, therefore it should be T, 5T. So this is the weight of pig. Then Go to the price for pigs. Price is P. This equal, it says 0.65, 65 cents mean 0.65, but is falling 1 cent per day. 1 cent means 0.01, but per day, that is, so we use how many days, t number of days, therefore 0.01 multiplied by t. Then go to the cost of keeping pig. So this is the cost of keeping pig. We know that it says and cost 45 cents a day to keep. Okay, therefore 0.45 per day. And how many days? T days, therefore T. Then we will write an equation for the R, which is revenue or income. How do we find the income? Price for pigs. Price for pigs multiplied by weight of pigs. Multiplied by weight of pigs. PW. So we can write down PW using this P and W. So let me write down this 200 plus 5t multiplied by, yeah, it is actually W, so P 0.65, 0.01t. Okay, that is the revenue. Then how do we find the profit? This is simple P, so this is capital P, profit. How do we find the profit? We know revenue, which is income minus cost, that is the profit. Next, objective. What is our objective? Maximize the profit. So maximize the profit. We have objective here. So now we are done with step 1. So then go to step 2. What is the step 2? Step 2 is to select the modeling approach. We know this is one variable optimization problem. So we can write down y equal fx is the equation. Then we can get the first derivative, set this equal 0 and solve for x. So this is the modeling approach in step 2. Then step 3. Step 3 is to formulate the model. How do we formulate the model? We know profit equal R minus C, and R is the revenue, which is P times W minus cost point C 0.45 T. So then you can plug the values of simple P and W what we have under step 1. So go back to step 1 and check the values. So you will see these are the values minus 0.45 T. Then we have actually an equation, profit equal and this. So we can take y equal P and x equal T. Then you will see y equal fx equal 0.65 minus 0.01x 200 plus 5x minus 0.45x. So that is an equation we use, but over the set S, define the x values here. We know x always greater than or equal 0. Okay, that is step 3. What is the step 4? Step 4 is to solve the model. So we know the fx. We write down under step 3. So let me write down again 0.65 minus 0.01x time 200 plus 5x minus 0.05x. So get the derivative of this first. F prime x equal, what is the derivative of this? You know how to get the derivative, but let me explain. Get the first, write down this one, then derivative of this, which is 5, plus get this one, then derivative of this, which is 0.01 x up 01 is negative, and derivative of this equal 0.05. So we can write down 0.8 minus 0.1x and simplify this one, 8 minus x divided by 10. So now we have a derivative of x. So set this equal to 0. Then you can solve for x. X equal 8. X equal 8. So you will get the maximum point of fx at x equal 8. So we can find the maximum point, then fx plug the x equal 8, which is f8 equal 0.65 minus 0.01 times 8, 200 plus 5 times 8 minus 0.45 times 8. So this should be 133.20. So this is the maximum of the f. We have only one point for the maximum, 8, 133.20. So since the point x comma y equal 8 comma 133.20 is the global maximum of f over the entire real line, it is also the maximum over the set S. S x greater than equal 0. Okay, now we know these values. Now go to the step 5. So what is the step 5? Step 5 is to answer the question. So we can say the answer obtained by our mathematical model is to sell the pig after 8 days. After 8 days. 8 days, thus obtaining net profit we can say $133.20. So this is the 5-step method. So hopefully you understood this method. Yes. In my next video, I will explain the sensitivity analysis of one variable optimization problems. Thank you.